So we have 5.5, 5.6 to cover. I forgot about 5.6. So it's applications in 5.6. These are just a lot of practice, but the concept is short. So here's the concept, and then we got to practice a lot in 5.5, and then do a couple applications in 5.6. So 5.5 is on U substitution. And this is basically the reverse of the chain rule. So let's recall chain rule. So let's let f of x equal, so we're going to do a derivative. And let's do the square root of 3x plus 5, just something like that. So we know you can write that as quantity 3x plus 5 raised to the 1/2. And then recall the chain rule, f prime of x is a derivative of the whole thing. So the derivative of the whole thing, so you're going to bring down the half, subtract 1, and then take the derivative of the inside of that whole thing, 3x plus 5, which becomes just 3. But that extra little factor of 3 that makes going backwards difficult. Or other things too, we'll see later. But so the derivative is 1/2 times what's inside. Subtract 1, you get negative 1/2. And then times the derivative of what's inside. So it's just 3 in this case. And so then possibly you might reduce that, right? But in this case, no, because it's a 2 and a 3. So this is just equal to 3 over 2 square root of 3x plus 5. So I just brought it down and made it a radical back. So if this is your derivative, we want to be able to go to here. So we want to go from here to here. So how would you do that? So let's look at another example. So anyway, that's what we're going to do. We want to try to go backwards and figure out some techniques to go from this to here. So let's look at this. So evaluate the definite integral of the square root of 5x plus 7 dx. So this is the technique you do. So we're going to let this be u. That's why we call it u substitution. So you say let u equal 5x plus 7. And then you do the derivative of that. Then you say du is equal to 5. So it's just 5. And then you say dx. And so what you get then is that du over 5 is equal to the dx. So you're going to end up substituting for dx this du over 5. So you say this is equal to the integral of the square root, and then make your substitution for 5x plus 7, which is just u. And then it's times your dx. But what's your dx? It is du over 5. And so I like to rewrite that. You could factor out the 1/5, and then it's just the integral of the square root of u du. We need everything in terms of u. You cannot have x in that substitution. So need all in terms of u. All right, so you do the integration, and you get that's equal to the 1/5, and then you get 2/3 u to the 3/2 plus c. And then you substitute back. The 1/5 c is just going to disappear. You don't need that, but because it's just a constant, so arbitrary constant is an arbitrary constant times 1/5. Substitute back, and you get where is it? You get, well, you can simplify, but you get 2/15, and then this becomes 5x plus 7 raised to the 3/2. Oh, I just multiplied there. That's right there. And then you just say plus c, because this was indefinite, right? This is indefinite. There's no values there. So a couple of things to check if it wasn't clear when you do that. Antiderivative of square root of u. Check that again. So that's the basic technique, and it's essentially applying the chain rule is what it's doing backwards. So here's the u substitution concept. Let me write it out for you, but mainly just want to be able to do it, but it takes some practice for sure. So what it says is this: let g be a function with range I and let f be continuous on I. So basically it's going to be a composite function. So the range of g is going to be the domain of f. If g is differentiable on its domain and f, capital F, is an antiderivative and I actually am saying an antiderivative because they're always plus a constant. So, but it won't. The constant won't matter. But I'm just saying an antiderivative. That's how. But there's little words like that that are very specific in math. So that's one of them. So of f on I. And so we're being careful, and you got to get past these little details of that. It's just basically a composite function, but I have to say where it's continuous and where it's defined. Okay, then, sorry about all that. Then we have the integral of f of g of x times g prime of x dx, and that's basically your chain rule, right? Is equal to capital F, the antiderivative of g of x plus c. So then details with u. So basically your u is that inside function. So let u, or if u, is equal to g of x, then du is equal to g prime of x dx. And so that's what you look for. You look for this, you look for this, g prime of x dx. And then you make your substitution for the u. You put it in. Okay, so you get that. And the integral of, you get f of u du, because that's what this becomes the substitution for right here. That becomes your u, and then you substitute for that. And that's going to be equal to your capital F of u plus c. Okay, so that's the concept and technique of how we do it. And then it's really, you really learn this one by practicing a bunch of them. So it does. This is one of those techniques that are a little strange at first. So, it's okay if you're struggling a little bit on these when you practice these. So, and to see what's going on. Evaluate the integral of cosine 4x dx. So basically, you got a picture. I mean, you can kind of picture what's going to happen. If you go reverse of that, you're going to get sine, but you have the 4 in there. So when you took the derivative, what happened to that 4? But now you want it to disappear. So you don't have to go through all of these steps, but this is what it looks like. If we let u be the 4x, then du is equal to 4 dx. So what I like to do is go ahead and solve for the dx if it's a constant like that. And then you know what to substitute for here. So the dx is the du over 4. All right, so then what you get is this is equal to the integral of cosine u, and then what was your dx? Du over 4. And so you can factor out the 1/4, and you're just doing the integral of cosine u du. And we know what that is. That's just sine. So it's 1/4 sine u and then plus c, because these are indefinite integrals. Now substitute back for your u. You don't want to leave u in there. So it's 1/4 sine 4x plus c. Now check this out though. If you just took the derivative of this 1/4 would just stay there. Derivative of sine is cosine times the derivative of what's inside, and the 4 and that 4 would cancel, and you have just that. So something simple like this, you don't have to go through this whole process, but that's the process you do to simplify it. Okay, let's continue. Next example. Evaluate the integral of x square root of x squared plus 1. So now we're stepping it up to more than just constants in there. And we want to see what happens with something like this. All right, so for this one, you got to picture the next step like 2 steps ahead. You don't, like, what do you pick your u to be? Well, you're not going to pick u to be that, because it isn't like it's not inside a function. It's not the reverse of a chain rule. So normally it's going to be whatever's inside the function. So this is going to be your u. Generally speaking, not every time, but sometimes you got to pick a u and try it, and then it may not work. And you got to do a different one. So if we let u in this case be your x squared plus 1, then du is 2x and then plus 0, and then you say dx. So what we do is solve for the x dx like this. So I like to divide out the constant and then see what you have here. So you have, here's your x dx, and here's your x dx. So that's what you substitute in for du over 2, and then of course your u substitution for x squared. So those are your substitutions right there. So you say this is equal to the integral. And so what does x dx become? That becomes 1/2 du. So let's put in the radical, square root, and that's u, and then there's your du. Normally I like to write that as 1/2 integral of u to the 1/2 du, like that. Okay. So this is how I want you to try to picture it. You got to picture both of these up here to substitute. Solve for the constant. Get it out of there. And then you look for that, basically that g prime and then the dx. All right, so now so go ahead and do the antiderivative here and simplify it. Okay, so you get, this is equal to, and then it's going to be 1/2. And then you add 1 and divide, so it's going to be u 1/2 plus 1 over 1/2 plus 1 plus c. Let's go ahead and simplify that down a bit. So it's 1/2, and that's going to be u to the 3/2 over 3/2 plus c. And at some point we'll substitute back. So that's going to be 2/3. So that's just a 3. U to the 3/2 plus c. So we can go ahead and substitute back now. So it's going to be 3 x squared plus 1 raised to the 3/2 plus c. And if you like, you can always check these. So when you check this, you're going to multiply by the 3/2 and then do the derivative of the inside, and that 2 is going to cancel out. So you can check it by doing the derivative. All right. Let's see. There's a couple more to do. Let's try another one. Let's see. Let's do this one. Integral of cosine cubed 5x sine 5x dx. All right, so again, we got to look like ahead. What u are we going to choose so that when you do its derivative, you end up with something else? So you kind of look, what's the furthest inside the function? Well, cosine cubed means this quantity, all of this thing actually cubed. So this is the furthest inside is the cosine 5x. So let's check that out. So that's going to be my first choice. So I'm going to let u equal cosine 5x. So do you see now ahead that when you do the derivative of your du that this will show up? That's what you need to have happen. So your du is going to be 5 sine of 5x, because you got to do the chain rule on that. Negative, sorry. Derivative of cosine is negative, so you've got a negative in there. So du is negative 5 sine of 5x. And so solve for the, dx, sorry, dx in there. Solve for the constant. So you have du over negative 5 is equal to sine 5x dx. So let's look for the sine 5x dx. So this is right here. So that's du over negative 5. And then your other substitution is u, which is your cosine 5x. Okay, so keep going. What does that look like? What's that going to be? So that equals negative 1/5 integral of u cubed du. That's it. And then you can easily do the antiderivative. So it's just 1/4 u to the 4th plus c. And then we continue to simplify. I'll just go ahead and work it out. 1/20. Substitute back. Cosine 5x raised to the 4th plus c. That's pretty much it. I mean, you could bring the cosine in, but that's it, basically. Okay, let's do one more. This one's from the book. I guess it's number 47. So this is x cubed. So try this one. I want to. This one takes a little bit of work. This one's a little different. So watch this. So let u equal x squared plus 1. So then you get that u minus 1 is x squared. So du is equal to 2x dx, or du over 2 is equal to x dx. And so I can then take the x cubed and break it up. So I can take this and say that this is equal to x squared times the square root of x squared plus 1 dx. And so now I have here's my x dx, and I have that x squared is u minus 1. Remember, you have everything in terms of u. And then do your substitution. So this is equal to 1/2, bring out the half, so 1/2 times the integral. So what is, so the x dx is just the du, but then what is x squared? X squared is u minus 1 times the square root of u du. Okay, so take a look at that, ponder that for a second. Then you distribute and you can just integrate. So you get the integral u root u minus root u du, and then you continue to work it out. You can check it yourself. 1/5 x squared plus 1 to the 5/2 minus 1/3 x squared plus 1 to the 3/2. Okay, so there's some work to do in here, but see if you can get it from there. So this is a kind of a next levels type of substitution where you have to actually solve for one variable or u and then rewrite it with u in it. Okay, so practice a lot of u substitutions. You have to get u substitution to move on in calculus. You have to understand it and be able to do all these problems with u substitution to move on. Kind of like factoring. You got to be able to factor to move on in algebra. You have to know u substitution method to move on in calculus. Okay, one section to go, and that's it.